All right, we're going to do our last video in section 2.3. We're going to finish it off with example 6, 7, and 8. Remember, we've talked in this section already about the notation we use for intersection, what elements are in A and in B at the same time. We talked about the notation for union, what elements are in A or in B, putting them all together. And then in a previous section, didn't we also do the complement of A, everything that's not in A? Well, now we're going to kind of combine all of them together. So it gets a little more challenging here. But what we're going to do is we're going to take it step by step. And it's really important that you're very careful and that you go step by step and you're very clear and organized in your work because you'll make less mistakes that way. And so we're going to go ahead and perform some what we call set operations. When you see parentheses, though, when we're doing set operations, you have to make sure, just like if we were doing mathematics, that you do what's in the parentheses first. So in this case, we would do the union of A and B first. So what elements are in A or in B? And I would like you to write those down. Once you have those elements, then we're going to figure out what elements are not that answer. And so we would apply the complement afterward. You do the parentheses first, and then you apply the complement later. Versus if there are no parentheses. In this case, you would do the complement of A, write down all the elements that are not in A. You would do the complement of B, all the elements that aren't in B, and then you would find their intersection, who is in their overlap, making sure that you follow step by step and you're clear with your work. Let me show you. In example 6, it gives you the universal set, which looks like it has the elements 1 through 10. It gives you set A, which is 1, 3, 7, and 9, and it gives us set B, 3, 7, 8, and 10. So on this particular example, they list it out in roster method instead of giving us a picture. So let's try it, do it this way. So for part A, we have parentheses. That's the first thing I see. And so I want to make sure that I do that first. So in this one, we want to do the parentheses first, which is the union of A or B. What elements are in A or elements in B? Remember, union means we're going to bring it all together. So I ended up getting 1, 3, 7, 8, 9, and 10. That's all the elements that are in A or in B. Now I'm going to apply the complement symbol, so the symbol on the outside, meaning I want all the elements that are in our picture or our universal set that are not any of these elements. So what elements are not 1, 3, 7, 8, 9, or 10? Well, I ended up getting a final answer of 2, 4, 5, and 6. But do you see how careful I was with each step? I wrote down this first step, I did then the complement, and so I was very neat and organized. The more organized you are, the less mistakes you're going to make. Also, that's a way I can give you partial credit. If you miss something little, I can at least follow your process and give you partial credit. I can give you as many points as possible as long as I can see all of your work. Let's do another one. In part B, it doesn't have any parentheses. So that means we're going to do each piece separately and then kind of combine them. So the first thing we need to do is we need to do the complement of A. What elements are in our universal set that are not in set A? Write them all down. I ended up getting 2, 4, 5, 6, 8, and 10. The next thing we want to do is figure out the complement of B. What elements are not in set B? What elements are in our universal set but that are not in set B? Write all of those down. I ended up with 1, 2, 4, 5, 6, and 9. And then, now that we've done the complement of each one, oops, sorry about that, we can do their intersection. So what elements are in this first set and in this second set? Remember, intersection means where they overlap and they are the same. And so what elements are in A and in B? I ended up getting 2, 4, 5, and 6. Happens to be the same answer as the first one. But again, do you see how I was very neat and organized and I showed you each of my steps? That way I make less mistakes instead of trying to do it all in my head. All right, here's example number 7. This example looks a little bit different because now they gave us a picture, a Venn diagram. And so can we do the same thing, but this time with a picture? I'd like you to try it. I'd like you to pause the video. I'd like you to use this Venn diagram to answer the following pieces. See how far you can get and see if your answers match mine. All right, for part A, it wants us to find the intersection of A and B. what elements are in both set A and set B? Well, I got the overlap that has the element 5 in it. All right, so part B has parentheses again. Remember, when we have parentheses, we've got to do that piece first. So what was the intersection of A and B? Remember, that was the element 5, right? Oops, I just erased it. And so now I can apply my complement. So now I want to know for my final answer, what elements are in my picture that are not the number 5? So if I cross off this element, what other elements are in my universal set? Well, I have the numbers 2, 3, 7, 11, 13, and don't forget about 17 and 19. Aren't they part of our universal set? But they're not the number 5? So my final answer would be 2, 3, 7, 11, 13, 17, and 19. All right, look at C. Part C says, I want to find the union of A or B. What elements are in A or in B? Remember, union means we're going to bring all their stuff together. So that means I want to list all the elements in A or in B. I got 2, 3, 5, 7, 11, and 13. Did you? All right, let's keep going. It says here in part D that we want to, I see parentheses, so that's what I'm going to do first. I need to find the union of A or B. Remember, we did that in the last part. So that should be the numbers 2, 3, 5, 7, 11, and 13. And now I want to apply the complement piece. So what elements are in our picture that are not the numbers 2, 3, 5, 7, 11, and 13? Well, it looks like the only two elements that are left are the elements 17 and 19. Make sense? All right. Part E doesn't have parentheses, so that means I want to do each piece individually. I want to find the complement of A. What are all the elements that are not in set A? And I want to write those down first. Did you get 7, 11, 13, 17, and 19? Then I want to do the next piece. I want to list out all the elements that are in B. See, there's no complement symbol there, so that means I want the elements that are in set B. And I want to write those all out. I got 5, 7, 11, and 13. Now I can put them all together and do the last piece and find their union. Remember, union means what are all the elements here or in here, and we're going to bring all of our stuff together. So we're going to list all the elements that are in both of those sets. I got 5, 7, 11, 13, 17, and 19. Now you could repeat them if you want to, but remember, repetition and order doesn't matter as long as I make sure that I have all of those elements, 5, 7, 11, 13, 17, and 19. All right, try F if you have not yet. I don't see parentheses, so I'm going to do them in separate pieces. I want all the elements that are in A, 2, 3, 5. I want all the elements that are the complement of B, everything that's not in B. I got 2, 3, 17, and 19. And then I want to put them together and find their intersection. So what is the intersection now of these two purple sets? Remember, intersection is what they have in common, A and B. So I end up getting 2 and 3. Those are the two numbers, two elements that are in both of those sets, 2 and 3. Keep practicing. I know that's kind of complicated, but remember, be organized, go step by step, and that should help alleviate some of your mistakes. All right. We've kind of already been talking about these words in the past videos. Remember, sometimes we use the word or and union interchangeably. What elements are in A or in B would be the same thing as the union of A and B. We also interchange the words and intersection. What elements are in A and in B means their intersection, where they overlap. All right, the last little thing that we're going to talk about here is finding the number of elements. Remember, this little N symbol means the number of elements in A or in B. Maybe you don't know how many elements are in A or in B. You can figure it out by figuring out how many elements are in A, adding them to all the elements that are in B. But you've got to be careful. If you've taken all the elements that are in A and you've put them together, and then you've taken all the elements in B and you've put them together, if there's anything in their overlap, you've just included that twice. So you've got to take out one of the times that you included it. So be careful with that. Let me show you an example. It might make more sense. In our last example, number 8, it says some of the results of a campus blood drive survey indicated that 490 students were willing to donate blood. 340 students were willing to help serve free breakfast to the blood donors, and 120 students were willing to do both. How many students were willing to either donate blood or serve breakfast? Well, I can figure out how many students were willing to do A or B, the union, if I know how many students served breakfast, how many students donated blood, but make sure that I don't over include any of my elements, and I've got to take out the amount that I overlapped, how many were in both. So how many students were willing to donate blood? Well, I got 490, right? And how many students were willing to donate, or not donate breakfast, but make breakfast or serve breakfast? I got 340. But be careful. We included all of those people that were willing to donate blood and all of the people that were willing to serve breakfast. But do you notice that I just overlapped them twice? I included both people twice. And so we are not going to get an accurate count if we just take the 490 plus the 340. We've got to subtract off the amount that's in their overlap, the 120, because we've included those students twice. So really, a more accurate answer to the number of students that are willing to either donate breakfast, donate blood, or serve breakfast would be 710, subtracting off that 120. I hope that makes sense. Let me know if you have any questions. That was the end of our section 2.3.